Hi, Katie here with your GalcoTV Industry update. This week we're talking about Eaton sponsoring the University of Michigan's solar car team, Red Lion's new remote monitoring software, and cooling buildings by beaming heat into space. Eaton has announced that it will sponsor the University of Michigan's solar car team for the next 2 years, and they will also provide products for the vehicle and engineering support for the team. U of M's solar car program is a student-run team that includes participants from the university's engineering, computer science, and business school disciplines. The team's mission is to design, manufacture, and race a solar-powered car in competitions throughout the world. Since the program began in 1990, 14 vehicles have been built, and the team has won the American Solar Challenge 9 times, placed third in the World Solar Challenge 5 times, and won international championships. Eaton will provide technologies and components to make the car safe, reliable, and efficient as possible to maximize the power harvested from the sun. These include a battery master power controller called Flex HVDC, which is a power distribution technology that manages high voltage power distribution. Components to raise the vehicle's solar panels to the proper angle towards the sun, allowing for a precise actuation of the 16-foot-long solar array and Busman electrical fuses. The newest solar car was unveiled on July 7th and will compete in the 2017 World Solar Challenge, a 3,000-kilometer race through the Australian outback from October 8th through October 15th. The car also will race in the 2018 American Solar Challenge. Red Lion has announced the introduction of their new N-View 2 software. This window-based application advances the functionality of Red Lion's existing N-View monitoring technology with centralized firmware management and enhanced network discovery for select N-View-capable N-Tron switches. These capabilities reduce administrative time, which is particularly helpful in managing complex networks. For industrial networking customers with multiple switches installed per location, N-View 2 allows scheduling of firmware updates by model individually or in groups, with mass firmware maintenance and monitoring of multiple devices from a single application. By automating activities that previously required manual updates, network administrators are able to streamline and accelerate deployments and maximize network uptime. N-View 2 is included with all N-Tron series N-View capable switches. A new extra efficient form of air conditioning developed by researchers at Stanford may be making our summers a little more comfortable while also saving on energy costs. This new form of passive cooling can cut the energy used by conventional building air conditioning systems by over 20% in the middle of summer. It works by chilling water by a few degrees with the help of radiative panels that absorb heat and beam it directly into outer space. This method requires minimal electricity and no water evaporation, saving on both energy and water. The researchers want to use these fluid cooling panels to cool off AC condensers. They first reported this idea in 2014, but have now made tangible progress implementing the idea. They have also established a startup called Sky Cool Systems to commercialize the technology. These radiative panels contain layers of silicon dioxide and hafnium oxide on top of a thin layer of silver, which combine to radiate the heat in a unique way, essentially bypassing the Earth's atmosphere and sending the heat directly into outer space. They are able to do so by emitting heat at infrared wavelengths between 8 and 13 micrometers. This new fluid cooling system attaches the radiative panels to an aluminum heat exchanger plate with copper pipes embedded in it, which is then enclosed in an acrylic box covered with a plastic sheet. Over 3 days of testing on a Stanford campus rooftop, they found that the water temperatures went down by between 3 and 5 degrees Celsius. The only electricity that the system requires is what's needed to pump the water through the copper pipes. Water that is cooled by only a few degrees can make a big difference. The electricity needed for a cooling system is reduced by 3 to 5% for every degree Celsius that the condenser temperature drops. A model showed that cooling a 2-story commercial office building in Las Vegas with fluid cooling panels, which covered 60% of the roof, cut the building's electricity use by 21%. Compared with using only a traditional fan-based condenser during the hot summer months of May through August. That is it for this week's Industry Update. Tune in next week for more of the latest news in electronics, automation, and robotics.